Last time I had a discussion in terms of how we can use two pointers. Now I wanted to give another type of example. I wanted to give a more detailed example and one walkthrough and a potential application. So the question that you're likely to get that can be solved in this way is something like a meeting planner. So the idea is, if you're given two individuals who have slots, you're given a set of slots. So let's call them slots A for individual A and slots B for individual B and slots B for individual B. Then you need to find a slot. Of course, usually given a duration, so you need to find a slot that works for both people. It's going to look something like this. So if this is a person's day, you're going to have separate blocks. The person is going to have some blocks. So the idea is, if the duration that is needed looks something like this, so the question is, where would this particular duration fit? So you'd see, okay, in this slot could maybe fit there, and maybe it can fit. Okay, the timing here doesn't work. Maybe this is the next closest thing that I can find here. So maybe this is the next closest thing that you can find. Okay. So the idea that you need to find a time slot that works for both individuals. So how do you go doing that? Usually you'll find the times that have been given in the slots are in, I think it's called an epoch time. The reason why that is important is that it certainly guarantees that it's going to be a non-negative integer, and that usually means the number of seconds that have elapsed since last day, 1st January 1970. I guess maybe that's why when computer started, I don't know where that number comes from. I should research. Anyway, so the idea is you have two slots, slot A, slot B, and they'd have this information. So let's see how the code would actually look like. So it looks something like this: slot A, and then maybe start time, something like that, 20, something like that, and so on and so forth. And then you'd have slot B. It would look something like this as well. So again, you'd have maybe different slots, right? So maybe for the person in slot B, maybe has, I don't know, time 0 to 15, maybe 60 to 70, and so on. And then maybe you have a duration that is needed. So let's say the duration is something like let's just make sure that it can match, right? So I have 60 to 110. Okay, so I think we can 10. So if the duration is 10, then you should be able to match these two items. So then the question is, how would you go about solving such a problem? This is again where two pointers comes in. So one of the things you want to do is you want to initialize the pointers here. So getting this data that you have. Maybe let me do a more full example. So for slot A, you want to look at it in this way. You have maybe go through some set data here, maybe 10 and 50, 60 to 120, maybe 140 to whatever. I don't need that as much. And then we'd have slot B, and then I have actually taken an assumption here, which I should make explicit, that these items are ordered. That is, the pairs that you get are actually going to be in a pair that makes sense. Maybe 150 to 180. Yeah. So I said 140 to maybe 70. Right. So we want to find the earliest time that works between slot A and slot B for a meeting that would have a duration of say 10 seconds. So how do you go about that? So the first thing is we want to start by setting a pointer. So the first pointer we'll look at slot A. So just pick the first item, the second pointer will be on slot B. So once you put in the pointer there, the next thing is you want to get in as much as possible, see if there's an overlap between these two. So you want to just make sure that these two match. So to make it a bit clearer, I'm going to bring these two slots in. So we have 10 and 50 and 0 and 15. So how do we check that? Well, on the smaller item, you want to get the largest number. So get the largest here. On this other side, you want to get the smallest, because then if you get the combination of the largest number here and the smallest number here, then you get where that intersection is based on, remember my illustration here. So you get where that number has come from. So how do we do that? We can use something like a max, right? So we want to get at, remember this they're always going to be what's it called? They're always going to be integers, and they're always going to be 2. So you know the indices to use are 0 or 1. That's it. Here's how I do it. I'd get the max. I try to get the max value, and then I'd do, at this point in time, this is slot A at 0.0, right? And this is slot B at 0.0. So then I'd get the max of slot A at 0.0, but I also want to get 0 again. All right, so it's either the max of this number or slot B at again 0, 0 again. So this is how I get my start value, and then get my end value. So how I'd get my end value would be by doing the mean of the slot A, but now we get the second value. So but we're still looking at the 0, so this is still 0, but now we look at 1, and then slot B again, the 0 part, but now we look at 1. Now we know for this slot whether the start and end make sense. So then we'd say we would kind of check, is end minus start the duration that we get here, because this gives the duration that is this less than or equal to the duration. If it is, hooray, we found our answer, and we can just return that and return the answer. If not, we go through that loop again. So now the next item will be we need to move the pointer to the next available slots. If resource was not found, you need to move to the pointer to the next spot. Now the question is, which pointer should we move? So looking at it, we want to look at if for this, in this particular case, we can see that slot B for this individual is the one that ends a bit earlier. That means that there is a possibility that the next number would still fit in this slot. Let's assume, just for the sake of this argument, we had something that was 10, maybe 20 to, I don't know, 20 to 30. So if this slot existed, one that was 20 to 30, then that could have fitted here. And that's why we advance the one that the largest number is still the smallest. So we keep the pointer for slot A, we move the pointer for slot B. How does that look like? Well, basically at this point in time, we want to check if the slot, right? We want to check if the slot A remember we were the 0th one, and now we're looking at the last one. So we want to check if this is the one that is bigger, right? Slot B, and writing is so bad. Anyway, slot B, and then we have at 1.1 slot B at 0.0, and then we have 1. So we want to check, so if this one is the larger one, then what we actually advance is this item. So then we would change the index, and we would repeat this entire calculation. So How do we change this base case into a loop? Well, just need to put this as an I now. Remember, we were just checking the first item, but now instead of only checking the first item, we can check the ith item, right? So you can now say, okay, I'm checking the ith item here, and I'm checking the ith item here. In this case, so everywhere had changed, and now so this is the jth item, sorry, because I had 2 pointers. So I'm going to call this pointer I, I'm going to call this pointer j. So this is what I need to change, the ith and the jth one. All right, so then after I've changed this one, so if this is a smaller one, then I do j plus equals 1. Else if okay, else, because there's only one option, right? Maybe this one is a bigger one, then I'd advance the other one. It doesn't matter if they are the same. It kind of doesn't matter any that you choose to advance, because then in the next loop that will resolve by itself anyway. All right, so that's the general reasoning behind it.